Another unique car we have in our collection is a 911 aerodynamic study from 1984. If you compare this prototype to a normal 911 from 1984 G model, it has some special details. If you look at the rear spoiler, that's absolutely different. The car has some covered wheels. It also has a different front spoiler, and at the very end, all these ideas they made it possible to have an aerodynamic coefficient of 0.27. A normal 911 at this time had a coefficient of 0.40. So this car was leading into the future. If you take a closer look at this aerodynamic study, you can always find some elements which made it to serial production later on. So this car is still a G model, but it already has some details of a 964 and a 993 as well. So our engineers took some ideas of this study and used it later on for the serial production. So the aerodynamic study is an example for the ideas of the Porsche engineers which came up in Weissach and made it into serial production sometimes 10 years later.
Welcome to the wind tunnel in Weissach. As we already know, Porsche opened the aeroacoustic wind tunnel in the Development Centre in Weissach to simulate extreme conditions and to test every new sports car and its rear wing. Today, we will look at 5 wild spoiler and rear wings presented by Norbert Singer, former race director.
Here we have one of the most advanced wind tunnels currently available, with a diameter of 8 meters and a blower output of 9,000 horsepower.
Number 5.
This is a Cayman GT4, built for the road but designed for racing. It boasts a mid-engine concept with sophisticated aerodynamics and a fixed rear wing supported by a rear spoiler, all of which produce plenty of downforce.
Number 4. Rarely has a rear wing been so perfectly integrated into a car's overall aesthetic as in the 959. It was based upon the 911, but faster and more powerful. Number 3.
Here we have an icon, a 2.7-liter 911 Carrera RS.
The 911 Carrera RS 2.7 was introduced in 1972 at the Paris Motor Show.
And its trademark was this rear spoiler, known as the ducktail. It kick-started something of a revolution back then, the discovery of downforce for road cars.
Number 2.
Here we have a Panamera Turbo. It has a V8 engine that delivers 550 horsepower. One of its great features is active aerodynamics. The spoiler deploys at 130 kilometers per hour, providing excellent balance at maximum speed.
This generates an additional boost and lets the driver feel every single one of the Panamera's 550 horsepower at the same time. Practical and performs well. Number 1. Saving the best for last.
Here we have the Moby Dick. It's based on the 911, even though it isn't instantly recognizable. Its outer shape is dictated by aerodynamics. It hit 366 kilometers per hour at Le Mans, so it was already pretty quick. The wing was extremely lightweight. It was made of fiberglass. Carbon fiber was still a long way off. It was nicknamed Moby Dick because it was very wide and was originally painted white, hence the name Moby Dick, the white whale.
Adaptive aerodynamics extends beyond the limits of any conventional sports car. even one with the airflow as well optimized as on a Porsche 911 Turbo. More than on any other vehicle, the aim was to make the range between efficiency and circuit performance as wide as possible. The 911 Turbo is able to repeatedly adapt its aerodynamic shape to the current situation and driver preference. Passing the 120 km/h mark for the first time, Porsche Active Aerodynamics now switches automatically to the speed setting. The active front spoiler partially extends. Only the outer sections are lowered. Less air resistance for less fuel consumption. Simultaneously, the active rear wing rises 25 millimeters. The rear wing concept produces its effect: downforce with efficiency. The airflow pattern shows why the new 911 Turbo is again the most efficient of all super sports cars. Its sophisticated cooling system accounts for just 4% of the total air resistance. The charge air cooler's characteristic inlet is ideally positioned within the side airflow. It passes the heat exchanger only just ahead of the outlet and thus provides optimum cooling. Pit stop, racetrack, the acid test for any Porsche. A gentle press on the performance button. For the driver, time for the great entry into the world of the super sports cars with aerodynamic downforce. The 911 extends its claws. Front spoiler and rear wing shift to maximum downward pressure. The fun can begin. Full throttle. The air flowing by presses the 911 Turbo ever more firmly onto the track. At top speed, the aerodynamic downforce reaches a total of 150 kilograms. Behind the fully extended front spoiler, the underpressure sucks the nose down. At the back, the split wing extended 75 millimeters and angled at 7 degrees presses down on the rear axle. Never before has the 911 been so dynamic. Nor so sure-footed. Thanks to highly effective brake cooling. Up front, diffuser and brake air spoiler direct the airflow to where it's needed. At the rear, a new air conduit system additionally sweeps cool air onto the brake discs and brake caliper, because more downforce enables better braking. Another advantage of active aerodynamics. Measured, it's 2 seconds better. That's the extra speed that active aerodynamics gives the new 911 Turbo on the Nürburgring.
durch mit der Bremsbelüftung?
Ja.
Ja, wir hatten doch hier über die Bückteiloptimierung gesprochen, wo wir auch lange mit Styling diskutiert haben und hatten mal wirklich jetzt eine gute Form bekommen. Kannst du genau in der Ebene nochmal einen Set-Schnitt jetzt durch das Modell durchgehen?
Das ist der Rechnung vom 92 im Winter. Wo genau möchtest du denn hinschauen?
Ja, ich möchte mal schneiden.
Okay, dann machen wir mal schnell einen.
Wollen wir mal ganz sicher schnell was wechseln?
Ich kann alles wechseln. Wo genau möchtest du denn hinschauen?
Ja, ich möchte.
Making a car, you want it to be efficient. You want to reduce that aerodynamic drag as much as you can. The Porsche Taycan can have an aerodynamic drag coefficient as low as 0.22. That's low. It's the slipperiest production Porsche ever made. There's nothing more aerodynamic on the road today, electric or otherwise. Like most electric cars, the batteries are located on the bottom. The bottom can be completely smooth and flat, allowing air to streak by. When the conditions are right, the car's body lowers closer to the road to create an even more streamlined configuration. Vents close in the front of the car to direct air around the wheels. The wheels are specially shaped too. They direct airflow through them, further reducing drag and cooling the brakes at the same time. Also, aerodynamic shapes look cool.